think we're good. All right. So I'm trying to remember where we left off here. Oh yeah, we were putting custom icons on there. And we're gonna keep working with Leaflet, but I'm going to be using some other APIs from the other packages with it. So I think the next one I'm gonna do is I'm gonna talk about Dismo. And so like we're starting to get into like my little corner of R, like what I use R for, because we're getting, towards the end of class, and there's like I'm reaching the end of like where I've experimented with R. So I'm gonna start talking about some of the packages I've used for my research, and since I do distribution modeling, Dismo's one that's come up for getting species information. And so Dismo has a API in it that goes onto the GBIF, the gbif.org website. Let me pull that up. Has anyone worked with GBIF before? It's like the Global Biodiversity Index something. Let me just pull that up quick. Basically, it's a bunch of occurrence data of, any species that's listed in their database. You can see they have a ton of occurrence records and data sets. So this is really handy for me if I'm trying to map some invasive species or like in my case, biocontrol agents of those invasive species. And for a long time, I was just, searching in GBIF like the species that I wanted. This is one of mine. Syringus constrictus. And then pulling it up, and they've got some like occurrence data, and you can download a CSV, and the CSV is kind of like pretty ugly, and I'd have to clean it up and stuff like that. Oh, someone added new pictures of it. Oh, I think that was us. Okay. Anyway, so they've got pictures and occurrence data and CSV that you can download. And I recently found out that all of that I was doing was kind of all for naught, because Dismo has an API to GBIF right within it. So I can just call, let's see, I want to make sure I don't skip anything. Yeah. So I can just use, I'm going to do CC because I'm going to get that same species, Pseudorhynchus constrictus. It's a weevil. And I can use the gbif function. Oop, and see, it showed up. It's in Dismo. And it just talks about, like, it uploads occurrence data from gbif.org. So I'll call gbif, and then it takes two strings. It takes the genus name and the species name, so getting pretty specific here, but focus for the genus name. And I'm just realizing now how weird of a word that is that I'm making everybody type in, but sorry. Weevils are notorious for having like ridiculous names with H's in places there should not be H's, but and then what else I have to do? Yeah, so this should pull the occurrence record from GBIF. And it says 342 records found, and it's working on it. Records downloaded. That's a lot. Wow. Used to be less. And now I'm just going to subset that. I'm just going to call it like locs for location or something short. I'm going to subset that into just, so it will download like a lot. Let's see. Let's look at the head of CC actually. Yeah, it gets like a bunch of, I told you, they're like really scary CSVs. There's like a bunch of information there and metadata. So I'm just going to subset out the location data that I want. Oops, I was going to say it was locs. So I'm going to subset the CC data frame, select equals. I'm just going to select the variables that I want. So I'll take the country actually that they're in, the lat and the long. That's what they're called. Okay. So just subset that. So, folks, much better. So you can see there's a lot of locations in Central Europe. and into Sweden and stuff, into Norway. And then I also ended up finding out while I was troubleshooting this that there were some errors in the lat data. And if there are any, like, there were errors in that they were like above 90 and stuff like that. And if there's any errors, it won't map it. Like if there's NAs and stuff, it won't map it. So I'm just going to get rid of those real quick. That's all I'm doing. So I'm going to subset again. Subset that looks and get rid of those the ones in the lat column that were wrong. So we're lats. Yes. Yeah. So I'll just put discard errors next to that. Errors. Okay, so now we should be able to map it. I'm going to use this coordinates, which is in the SP package, actually. That's going to set the spatial coordinates for those lat longs. So coordinates, locus, and I'm going to assign it those lat long variable or column names. That's just what they're called. Okay. All right. Yes. Oops, I might have switched those around. Let's see. Plot. Let's see. Plot. Oops. So now it's just plotting them in space. I don't have any base map or anything. I think I'll just double check that this isn't. Okay. Okay, I think it's good. All right, so now I've got the spatial points for the species. And let's see. Now I'm going to create a map of them. So I'm just going to call it CC map. I'm going to use leaflet again to create like a blank interactive map, a blank leaflet map, and then pipe onto that. Add tiles. I'll just add the, let's see. Yeah, I'll just add the standard tiles for now. We don't have to get too fancy with it. And now I can add the markers that are associated with the different points. Lat equals, and so this is what I was talking about, where you can set the lat to be equal to all of the lat variables within a data frame. So to do that, I'll do locus lat, and then equals one. That looks okay. I think that's all I need. Maybe I forgot to add something. Hang on, I'm a little worried that since I mixed my lat and long around, it might have messed with the SP coordinates function. So I'm just going to run it again. Let's see, we'll do from here. I'm just going to pause this. All right, so I just fixed it, put the lat long in the right order there, and so now I can do CC map. There we go. So that's where they are in Europe. That's the 300 or so location points that they just pulled from GBIF for us. And I really, let's see, I really like the I really like this one with the Esri Nat Geo world map, so I'm just going to throw that up there. Yeah, that looks good. I also just wanted to show that you can, as several of you talked about in your online learning activity 2 presentations, the SP package allows you to set coordinate systems and stuff like that and coordinate data, and you can do that with the points data here. So I think it's it actually might be CRS Geo. Oops. Let's see, what did I call it? Okay, so I'm just going to give it a name and assign the coordinate reference system to it. So that's CRS. And it's coming up with the SP package that takes the coordinate reference system as strings. And I'm not going to, make you watch me type that out because I'm like typing really slow up here as it is. So I'm just going to go like in a cooking show and just get that string. So here it is as a string. It's just like the WGS84. And I think that's what it is by default in this case, so it's not super handy here, but I'm just showing it to make a point. And let's see. So I run that. And then you can do that proj for string, which is also in the SP package. Proj for string. String, and so I can assign that projection string that I just did to locks, which I called CRS Geo. Yeah. Oops. What did I call it? Oh, underscore Geo. Yeah. So I don't think that one's super useful because I think GBIF outputs WGS84 anyway, but I just wanted to show that you can do that. And I can do summary locks just to show you it should say, yeah, and it's got the WGS84. So that's where I get like the string from usually. Like I either find it online or I do the summary of some other object that I know is in the projection that I want, and I like copy that string in. But that's just sort of an example of that. So I've gotten like pretty good at doing this for like resetting the coordinate reference system for point data and polygon data, but for raster data, not so much. So I've still been like kind of struggling with that depending on the raster format it is, but hopefully I'll figure that out at some point, but we don't need to do it today. And I also wanted to point out that you can add different types of point data to the leaflet maps. Much like you can with ggplot and stuff, like you could add different size circles or radiuses and stuff. So I just wanted to show an example of that. So like with those crime maps, some of them had like sort of the circles, and they might have had like bigger circles based on how much crime there was and stuff like that. So you can definitely do this with leaflet. So I think I'm going to go back to, let's see, were we calling it my map or was it, oh, I'll just call it my map. Oops. Leaflet. Add tiles. It keeps autofilling and I still try to type. And it's like, don't do it for me. And so you can add circle markers instead. And I'll do lat equals locus. Lat, we'll do it with this data on the right here with the pseudorgus constrictus data. And you can like define a radius. And I don't really have anything to define the radius to right here, so they're all just going to be the same, but I'm just going to set them to 4, but you could set circles of different sizes and stuff. If you had factors, for example. What was I? Oh yeah, I wanted purple. It's going to match nice. And you can change the color of your markers too by setting the color, I believe. And I'm also going to add a pop-up. Like we were doing earlier, and just show an example of how you can use that paste function to put some data, like custom data, into your pop-up, so you can have like a different pop-up for each one based on what their lat long is. And so I'm just going to use the paste function that you guys have seen me use before, that just sort of concatenates things together, sort of pastes things together like strings and data. Paste, and I'm going to do C constrictus, oops. And then it just takes, separators of commas for each thing that it needs to paste together. And I'm going to put in the lat and long data so that a pop-up will show up with their actual location. Okay, that's all I'm doing. And then my map. And there they are. They've got a certain amount of opacity by default. But yeah, I could definitely see like if you had data that had factors and stuff like that, doing like size equal to those factors and things like that with those circles. But I just wanted to show that they were an option for representing the point data. Okay. I'm just checking what to do next. All right, so now I'm going to get into the Raster package and using some of the APIs in there to pull data. So this one is one of my favorites to work with because I'm using it for my...
If you click on one of those points, does it show?
Oh, yeah, that's right. I totally forgot. Thanks for reminding me. I put that in and then I didn't show it. So yeah, so now when you click on it, it will put in the actual location of each one using that paste function. So yeah, super handy. Yeah, thanks for reminding me. Forgot I did that. All right, so now I'm gonna get into the raster and we're gonna start pulling some climate data with this. We'll do like some climate data and some elevation data and then some terrain data. Raster climate. So this is using that raster package that we installed up here. It has a lot of APIs within it, and I have not even like scratched the surface with all of them, but I'm just going to show you two that I've used that are really fun to get data for. So the first one that I've used a lot is I get data from the, let's see, bioclim variables. So bioclimatic variables they're actually using like WorldClim as the database, and that has some raster layers for annual temperature, rainfall, and those sort of things. It also has climate change rasters, like, from based on a 30-year norm or whatever. But they also have these bioclimatic variables, which are really useful because they're just a little more biologically significant, like it's broken into seasonality and stuff. And so there's 19 of these, and there is a API within the Raster package that can grab variables from that WorldClim website for you. Like, we'll grab the raster layers for you. So I will just show that, and I'll just call it CCCLIME because I can actually get what the different climate variables are for where those points, like all of my location points, like intersect the within Europe. You can pull climate data for where they are located. So I'm going to try that. So let's see, it's get data. That is the function within Raster that kind of contains all the APIs. It's a little clunky because they don't have like a name for bioclim or a name for elevation that's its own function. Instead, it's just this get data function that recognizes different strings you give it, kind of like the install packages. It recognizes a string that it's going to go onto CRAN and get that package name. It's kind of like that. So I actually just give get data the WorldClim string. WorldClim, so it knows it's going on the WorldClim website. And I'm going to tell it that the variables I want var are, I think it's, what is it? Bio for the bioclim variables. I'm going to do it at the 0.5 meter resolution, which might take like a few minutes to get. And we want to give it the points. Longitude equals. These are the points it's going to get the data for. Okay, so now it's downloading. It actually doesn't take it to get that long to get a pretty fine resolution raster. It says it's downloaded. I'm having trouble clicking into my RStudio lately. All right, so it's downloaded the raster layers. I'm a little apprehensive to plot because I think it will plot like the raster stack for each of those 19 variables, but I'm just going to do it. Oh, I might have upset things quite a bit because I can hear my computer working. Hopefully I don't crash it. Okay, so then what it did was plot the raster stack for all of those variables, and each variable is named, and you kind of have to go back to that website to see what each one is. There's annual mean temperature, isothermality, which is kind of like temperature evenness and stuff like that. But most of the time you just want to get, certain variables out of there. You may not want to use all 19 of them. So we're going to do that next. So we're just going to do, I'm just going to actually plot one raster. I'll just call it R. And I'm going to do plot CCCLIME. But I'm just going to get out, using my double brackets subsetting, I just want to get out that third raster from that stack that it returned. And the third one was the isothermality, which is sort of like, I think that's what it was, which is sort of like temperature evenness, because it's mean diurnal range divided by temperature annual range. Okay, so I just want to pull that out. And that. And there we go. So it's just grabbed, since I did a pretty fine resolution, it's just grabbed the raster tile for that part of Europe where the points fall. And that's the raster that it returned for isothermality. Did I unpause this? Yes, I did. Okay. And I can also add my points to that. Because right now it's like, okay, there's a raster tile, so what? So I'm just going to add my points with the points function. Oops. Make sure I don't mix up my XY data here. Yes, okay. Oops, not. And then I'm just going to adjust the size of them here. I don't know what CEX stands for, but it's like the size of the radius of the points or something. And then I think it's the PCH is like the type of point it is, I believe. There's like, I think in this book, in R for Data Science, there is a reference to the different point types you can do, like stars and like circles and things. Pretty sure that's what the variable is. And there they are. They're not all on that tile, but it did grab tiles for all of them. If you do it at a lower resolution, you will get like the whole world map as well. Like it'll grab the whole world tiles. But it seems that when you do the finer resolution, it just gets like it just gets that tile for like the last point it executed it for. So that's. See, what else was I going to do? Oh yeah, and then I was going to use the extract function to actually extract where these points intersect the isothermality raster. So it's going to get the annual isothermality, or like the value for evenness of temperature, you know, whatever that output was for mean diurnal range divided by temperature annual range for where each of those points intersects the raster. So, oops, I keep trying to click up here. There we go. No. There we go. All right. So what did I say? So we're going to do CC extract the variables using the extract function from raster, which is actually pretty handy. And it will take that CC climb where we assigned the values that were pulled from the world climb data set for those points, which are the locus XY coordinates. Okay, and it takes a second. It normally doesn't take this long, but since my computer is running integrity, I think, and everything, it just takes a minute. And I'll just do CC. All right, and so what it returned was for all of the points, it's kind of hard to see in here, but for all of the points that I gave it, it's returning what those, what the variables are. And there's some NAs again, because remember there's like some that were like off the raster and stuff, but it's returning what the value was for isothermality, or that bioclimb variable 3, for each of those points. So where the point intersects that raster stack, what is the value in that cell, basically. So that's what the
Spatial join, basically?
Yes. Yeah. Mm-hmm. Yep. Yeah, so it's pretty handy. Mm-hmm. So that's one of my favorite ones to work with for climate data. I really like the bioclimb variables since I work with like plants and insects, and the seasonality of it matters. Because it has like min temp, like, where is it? Yeah, like max temperature in warmest month, coldest month, like they have a seasonal component to it with the averages. And you can, with these rasters, I haven't played around with this that much, but with these rasters you should be able to do, with the raster package, you could do your own raster calculations. Like you saw, it was a division of for the isothermally division of like the second raster and the seventh. Like you should be able to do your custom ones too. Okay, so let's get some elevation data, and then we'll do like slope and aspect, and then I'll move on to like the last bit, which is how are we doing on time? Yeah, we're doing okay. And I'll just move on to the last bit, which is I'm just gonna do like a brief geospatial analysis with a union of something. But anyway, so elevation data. This I recently was playing with, and it's super fun. So I'll just call it elevation for the name. Actually, I'll do I'm gonna grab Switzerland. Let's see. You give it the country you want the elevation for. So I'm gonna do Switzerland because that's the Alps, and there's gonna be like cool stuff to look at. And some of these points should be in Switzerland, I think. So again, it's the get data function. I don't know that I like that. I wish there was like a separate getter function for each one, but I don't know. And alt is the name of, I don't know exactly where it's getting the elevation data from, some website, but it's using alt to tell it what kind of data to go and get. That's what's telling the API to go get elevation data. And then you can say country. And then it takes the abbreviations of the country so far is what I've found out. So I'm going to do the Switzerland abbreviation, which is CH. And it got that, so oh wait, I need to plot it. I'll do it in here. There we go. So there's Switzerland. Oh, it doesn't show up very nice on this, but oh, and then if I did the points, let's see. Maybe I don't. I'll put that in there. Maybe I don't have any points in Switzerland, actually. Guess I don't know for sure. Anyway, let's try a different one really quick. I'm going to do I'll just say for Germany. Get data, alt, country equals abbreviation for Germany. Getting that. There we go. Oh yeah, there are points. Okay. They just weren't in Switzerland, I guess. Which is weird because we definitely get our population in the lab from Switzerland, so we're going to need to report that location to GBIF. Anyway, Germany's not as interesting as Switzerland for elevation data. If you're trying to get the elevation data for the USA, I think I need to go into the API and figure out how to do specific regions. I'm sure there's a way to not do it by country because the USA one will actually return a list of 4 separate elevation rasters that it's broken the US into, and I think they're just like probably tiles, like because the US is just covered by 4 tiles, but these countries are small enough that we can just individually get them. So just a heads up on that. And we have points in Europe for this example. All right, and then, all right, so I said we were going to do some terrain data as well, so I'm just going to like assign that a name again, and that's, you can actually use this terrain function that uses the elevation data to get the terrain. So this is like, there's analysis for this in ArcGIS, I'm pretty sure, to get like the slope and aspect from elevation data. It's like that. Options equals. I think these are the different analyses you can run. So I'm going to do slope and aspect for the options to run. And give it unit equals degrees for that aspect. Oops, needs to be. Oops. All right. Oh, that's right. I didn't call it elevation. I called it CH elevation. Cool. Yeah, so then it ran the slope and aspect for that elevation data in Switzerland. So yeah, I think that's about the APIs that I was going to show, and then a little bit of raster analysis there with the slope and aspect. Those are probably like the most common raster analyses I've done, since graduating, I think, for ArcGIS. But again, I'm looking at like species data and plants, and sometimes you need to know the aspect of the slope they're growing on and whatnot. So those were just the examples I came up with, but I am sure there's more that you can get out of it. There's so much in that rasters package. And by the way, I have linked, let's see if I can find, getting back, yes. I have linked to the documentation on these packages that we're talking about, SP. Oh wait, shoot, I don't have raster in there. I'll add raster. So a lot of these packages that we're talking about, I've just linked to the CRAN documentation about them, so you can read about them. A lot of times SP, I think SP also downloads when you install ArcGDAL, so you should probably already have it. But it just like has a description and very long documentation with everything that it does. There's way too many functions for us to cover. I'm just sort of like doing a preview and throwing the options at you, so in case you want to do something specific for your final project, you can take a look at some of these packages and see if they have what you need. Okay. So the last thing that I wanted to do was a little bit of a do a little bit of geospatial analysis. We just did some with rasters, but do a little bit with polygon data. So I just decided to get some like Minnesota data, which I just downloaded a shape file from, I think I got the county boundaries from Minnesota Geospatial Commons. So I already have that downloaded. So if you want to do that, you can really quick, or you can just watch me do this. It shouldn't take too long. And so I'm going to use the read OGR function because I want to read in this shapefile, which is in, oh, I might need to run, did I put RGDAL in there? Maybe not. RGDAL. Because it didn't recognize that. There we go. It's in there. Okay. And then I'm just going to put in the layer. I'm actually going to go over to my finished cooked product over here and get that path, because like it's not going to matter too much for you guys since it's specific to where I stored it. Go. And this won't take long. It shouldn't take long because it's just polygon lines. Yeah. So it's not nearly as big as the invasive species data. And so just plot that so we can see it. You guys know what it looks like though. County layers. Anyway. So I'm just going to do a spatial union. So this is just like the union that you would see in ArcGIS. They also have intersect as well. This is through the, I believe it's through the ArcGIS package. And so that's a really good one to look at if you're looking to do like your geospatial analysis, especially for the polygons here. And so all I'm going to do is like union some of the counties together, because this was just some of the data I came up with for just doing something that would load quickly, so we're not sitting here forever waiting for polygons to load and point files to load. So I'll just subset out some polygons real quick here. In, do that quick. And I'll do city name, I think, or CTY name. Sorry, because it's Ramsey County, not city. Ramsey. Get Ramsey in there. And we'll get Hennepin in there. It's so hard to type at this table. Hennepin. So plot Ramsey. There's Ramsey. Plot Hen. There's Hen, but they're not together. They're subsetted out. And so I'm just going to do a union, which, if you'll remember, is where Ramsey and Hennepin are. So it should do the space all within them. Oh, I'm just having trouble clicking up there. There we go. So I'll just call it union, and then it's using ArcGIS, which does G union. Yep, ArcGIS. There's pops up with some of the parameters it takes and what it does. Functions for joining, intersecting geometries. So they have to be adjoined in some way in order for it to do it. Let's see. And it just takes the two polygons that you want. Pretty handy. Oh, I called it union. Ugh. There we go. That's the space within both of them. So I could do that with a bunch of them if I just wanted to get like a certain section or the metro area or something like that. I could do it with different parts of the US, you know, just get the Midwest or something. They also have G intersect and stuff like that. So I just wanted to show it to you guys. It's in the ArcGIS package. Let's see, is it G intersection? Yeah, G intersect. Section and G intersects. I think it's G intersects. I just wanted to show you some examples in there. Of course, you could do it with like your point data, polygon data. And I haven't gotten too far into the world of geospatial analysis in R, but so far it's been easier for me with polygon data a little bit, because it's easier for me to get polygon data all in the same coordinate reference system. But yeah, so I just wanted to point out ArcGIS and that you can read more about it under that file that I posted. But so that's all of the demos. I just wanted to demo some of the APIs, mapping them within Leaflet, doing interactive maps. I'll probably let you guys start working on stuff that you want to work on, because we're now at 8:30. Like, that's kind of what we were hoping for. And then while you guys are doing that, if you guys don't have any questions, I'll start trying to put some in an R Markdown document so you can just look at like how it's zoomable in R Markdown and stuff, and take a look at that. So then maybe I'll also post the R Markdown on our GitHub examples page and stuff. But I will be adding comments to this along with the links to where I got some of the tutorial data. I changed it quite a bit for some of it, but I have been putting the links in there, so that will be up on GitHub as well. And those links correspond to these tutorials I have under the folders. So that's it.